Hi, this is Amin, and after having an introduction on 5G system, now it is the time to take a closer look at 5G architecture and deployment. So in this video, I'm going to talk about deployment and architecture of 5G system. This is the first thing that is important on the deployment. We should know about NSA and SA concept in 5G. What is NSA and SA? We have a standalone and non-standalone. What is non-standard? We know that. Let me explain everything on this slide. I think on circuit switch fallback video, I've told you about that. When service provider, when they wanted to implement 4G system, they didn't take off any UMTS 3G and 2G systems. Some losers like me, I'm still using a cell phone that does not support IMS calling, and whenever I want to make a phone call, my cell phone does circuit switch fallback, and it goes back towards UMTS system 3G. So my cell phone, and I mean all of the technologies are backward compatible. So as long as they're backward compatible, we can think of 5G NSA and SA. This is the first thing, and also we can say that whenever we have equipments of 4G, it's not logical. It will impose lots of expenditures to the service providers to take off everything related to LTE. I mean, not only the backward compatible and not only the thing that many subscribers, many users are still using 4G or 3G systems. Just put that aside. The other thing is that it will impose lots of expenditures, lots of money to service providers to take off whatever related to LTE and install just 5G system, as long as the LTE system can support and can run 5G. So we can, we have two scenarios. First, we can run 5G virtually on 4G system, or we can have both of them simultaneously. And whenever a UE, a cell phone, wants to have a connection, it sends a attach request towards the INADB, and then let me try it again. So the UE will send a request towards the INADB, and INADB will talk to 4G EPC to the core, and then the UE will signal the core via S1 MME that, hey, I can connect to the 5G system. And 5G will check that and say, we check the UE capability and say, yes, you can do that. It sends a message towards the INADB, and INADB will inform the UE via RRC config messaging. So the UE, and then there will be a bearer. They're going to set up a bearer here, and via this bearer, at the same time, the 4G can have dual connectivity. This is a non-standalone system. And also we know that wherever we have a 4G, they installed that in a somehow parallel way. Both of them are there. But for example, imagine you're gonna, install a 5G network on your factory. You have some sort of IoT scenarios or thoughts. So when there is nothing related to 4G and you're gonna start from scratch, it is more logical. Actually, it depends on your budget, but anyway, it is more logical to install 5G as standalone. So this is the concept of NSA and SA 5G. These are the information all of them related to that. I'm not gonna just mess around on that slides. If you want to watch them, or if you want to read them, you can pause the video and read all of them, or I'm gonna take a screenshot of that. But anyway, these are whatever I've told you. So in the deployment scenarios, we have two or three. We have two types of scenarios, which one of them is divided into two. So on the whole, there are three, but anyway, there are two. Homogeneous and heterogeneous deployment. What is that one? Homogeneous deployment. As we can see, where LTE cell and NR cells provide the similar coverage and also the same band. So in NSA, non-standalone scenarios, this is the thing that we'll see. Similar coverage, a similar band. So they call them as a homogeneous deployment. So the cells are co-located cells. These are the keywords related to that scenario of deployment. However, we can consider like this, in this way, that these two are the same. I mean, these two kinds of heterogeneous. We can consider that either LTE is larger than NR, or the NR is larger than LT in the cell size and coverage. So look here, for example, this color, this blue color, is the LTE, or this may be red or magenta, I don't know what color is this, but anyway, this is the NR cells. So the small cells and macro cells, and one of them could consider as hotspot. This is the second type of deployment, which we call that as heterogeneous, and we can see exactly vice versa. Now the NR is macro cell and LT is a small cell. So LTE core network architecture. Before going towards that, we should know about a concept which is pretty important, CUPS. Control and user plane separation, CUPS. This is the thing that happened in 4G EPC before 5G, but still it exists. So what's that? Look at that. This is the introduction of user plane and the control plane separation. We have user plane and control plane separation in 4G EPC. So instead of just serving gateway, what do we have? We have SGW control plane, SGW user plane. Or instead of PGW, we have PGW control plane or PGW user plane. And what is the reason behind that? So, before that, let me add another concept, and then I will tell you. I've told you LT was at release 8, and then before release 11, there wasn't any TDF, and from release 11 onwards, we have TDF, traffic data detection. And what is that? You are here, you want to, surf the net or make a WhatsApp or Skype video call. This is your data. If it was something like, signaling or tracking area update, this was the path for that. But here, your data goes here to the SGW and then to the PGW. They are working closely to each other, TDF and PCRF. PCRF will check, are you authorized? I don't know, for example, you have a plan, and your plan has a specific bandwidth or specific data usage. So this one will check, and then TDF, traffic detection function. No matter how much your data is encrypted, no matter, what kind of VPN you are using, TDF will help the service provider or will be able the service provider to monitor your data towards the outside world. This is the responsibility of the TDF, monitoring your data no matter how much it is encrypted. So bear that in mind. Here, what do we have? These things are, after CUPS, these things are split into two. So what do we have? Again, the same scenario, it comes here, 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 but it goes towards, this is a NSA, we have INAB, S1U, it goes towards, actually it's a 4G release 11. It comes here, but what do we have? Not only S gateway, P gateway, and TDF are divided or separated into two, but also the interfaces are divided. We know that we have S5, S8 for the connectivity or the connection between SGW and PGW. S5 is for the time that you are using your home network, and S8 is for the time that you are using a roaming service. You are not at your country. So whenever you are using your network, your home network, you have S5, and when you are using another country or another network, you are at S8. So S8 is for roaming. But here we have S5U, S8U, and also S5C, S8C because they are divided. So in this way, the data can communicate faster. At first step, it knows. Don't get me wrong. There are not different devices. There are not different modules. These two, for example, let me put it this way. These are still packed in one device, but the responsibilities are separated into two functions. So the data goes towards this one, and here, and here, and here. Yep. But we're not gonna just talk about TDF. I just wanted to mention because I wanted to talk about CUPS. The other thing which was separated was the TDF. So reorganization to our service. Now it is the time to somehow touch the functions inside the core. Look, we had HSS and AAA. We know that HSS does the authentication. When there is a UE, and when the UE sends a attach request towards the inadb, as it is the responsibility of MME, so inadb will send that towards the MME, and MME will send that towards the HSS. And HSS will at first check the subscription or identity of that, and then using AAA and add some keys. I've told you in LT security, adding the keys and then respond and set up a bearer and that sort of thing. So HSS and AAA are mixed to each other, which were there before. And now we have AUSF, Authentication Server Function, and User Data Management, UDM. So now instead of HSS, we have AUSF and UDM. So what else? PCRF, now we have PCF. Again, we know that. After this one was MME, this one was HSS. After that, when the UE wants to use a data, again, it sends a request, it goes towards the S gateway, and from S gateway it goes towards PCRF. We know that each request on the LT system has a QCI value, and based on that QCI value, the PCRF will assign a number which will give the UE a QoS. So PCRF was responsible for QoS in the LTE, and now it is the PCF, Policy Control Function. And also we have Access Mobility Management, MME. So MME now it is the AMF instead of MME. We have Access and Mobility Management, and MME, SGW control plane, PGW control plane are session management function. MME, SGW, PGWC all together are SMF, and finally SGWU and PGWU are UPF, user plane function. So now we can touch the concept, we can understand how they are divided or split each other to have new functions, and we should consider all of them as a function, not as a module or as a device. So let's see that one. Yeah, this is all of them. Whatever we have inside the core, UE, and the abbreviations are here, and also the description of all of them is here. I've told you AMF, which is resembling MME. So now we have NAS, signaling, ciphering, security, mobility management, authentication. I've told you about authentication in the last slide, which was responsibility of MME, and now AMF does that. We have session function management. Again, it is the combination of 4G, MME, SGW, and PGW. Allocate IP address to the UEs, and yeah, all of the things that I think I've covered all of them. But again, I'm telling you, you can pause the video and read all of them. UPF, SGWU, PGWU. Again, they're using for radio access network or for the interrat handovers. I have a video for interrat handover again on my channel. You can watch that. And I think on the video which is related to voice over Wi-Fi, on that video I've told you about interrat handover, radio access technology. And also PCF, again, the scenario that I was telling you. What was that? A UE sends a request towards the inadb and inadb to the MME or to the S gateway, and then it goes towards the PCRF. Now, PCF is responsible for whatever PCRF did in the past. Each request has a QCI value, and the QCI value will tell the priority of your request. For example, for phone call, for IMS calling, the QCI value is 1, and the lower number has higher priority. But maybe you just want to surf the net, I don't know, watch a video on the youtube.ca, so the QCI value is different number, and we know we have a guaranteed bitrate and non-guaranteed bitrate anyway. This was the responsibility of PCRF, and now QoS policy is responsibility of PCF. So let's continue. We have AUSF, which was the HSS, we can see here, and UDM again the same for the key agreements and key ASME, key NAS security, the things which were related to that. Whatever application that we're gonna run, they goes towards the application function and the network exposure function. It is for translation of internal external information, control plane parameter provisioning, and exposes capabilities and events. Like we had events, A3 events whatsoever, and A5 in the LTE. NSSF, I've told you in the previous video about slicing in the networks, so it is responsible for the network slicing, and that's it. Yeah, it's finished. It is the main architecture. We can see that. So now we have better understanding. Now imagine you're gonna surf the net, use a data or stream something on YouTube. So you send a request towards AMF, and then it goes towards here or here based on your request. AMF will talk to AUSF to check your identity, and maybe UPF will talk to, or SMF, it's better to say SMF, will talk to UPF. You're going to get an IP address, and we'll talk to PCF. Are you authorized to use that service? Do you have, I don't know, maybe there are some sort of services due to a high bandwidth, you need some authorization. Do you need ciphering, or which application you're going to run, so they're going to communicate to each other? And finally, you go to the outside world. And also, instead of internet on the instead of the name, the internet, we have data network, which is the internet. But I mean, in the architectures that you can find, I don't know, in the reference books or through the net, you'll see the name is DN, or data network. So anyway, this is whatever that I've prepared for you to talk, whatever I wanted to tell you about the 5G. I've made it in 2 videos. I hope you liked them. So if you like them, show a thumbs up, hit on the like button. If not, at least thanks for watching the videos. Don't forget to subscribe to the channel. Take care. Bye everyone. Bye.